Like that.
Are you on the web?
Yeah.
All right, so like I said, what we are focusing on today is writing the equations of lines. Depending on the information that you are given will determine kind of how you go about writing your equation. No matter what information you are given, we want to always write our final equation in slope-intercept form, which is y equals mx plus. Did you get it? I want you to remember that m is standing for our slope and b is standing for our y-intercept. It's important that you understand what the variables are standing for. What we are going to eventually use today is our point-slope form, which you would have used quite often in Algebra 1. Y minus y1 equals m times x minus x1. Again, where m is standing for your slope, and the point x1, y1 is a point on your line. We are going to start off pretty simple. We are going to start off where we are given both the slope and the y-intercept. So all we need to do is replace those numbers in for the slope and the y-intercept in our slope-intercept form to write our equation. So if you look at the first example, we are told that the slope is 2 and the y-intercept is -5. So remember, in your y equals mx plus b, m is your slope, and b is your y-intercept. So all we're doing at this point is replacing 2 in for the slope, -5 in for our y-intercept. For the second one, similar type of thing. We're given the slope is 0. We're given that the y-intercept is 1. So we will substitute 0 in for our slope and 1 into our y-intercept. If you want to leave it like that, that's fine, but we typically would then just write y equals 1. What kind of line is that has a slope of 0? No. What? No. This is horizontal. Okay, this is horizontal. All right, I'm going to give you 3 minutes with your table to do C and D. 3 minutes, go.
How was your weekend? Pretty sure that's wrong, right?
That's right.
That's right? God bless America. Wow, what is it? Okay, good, fine.
Josh, what equation did your group write for C?
Like the final thing or like how
Yeah.
we did it?
What's your equation?
What did we were still in the process of it. We were doing that slope thing.
No, don't have to do that.
You don't have to do that.
No.
At first I just said y equals negative 1x plus 4.
Yeah, that's all it is.
Okay.
Y-intercept at 0, 4, that's the same thing as saying the y-intercept at 4. This is just written as an ordered pair. You don't necessarily have to have that 1 in front of the x, so either way that you wrote it there is fine. All right, McKenna, what did your group say for the last one? Good. If you had plus 0 on the end, that's fine, but you absolutely don't need it, okay? All right, so making it a little bit harder now. What we are given, and you did this a little bit on Thursday in your group work. Now we are given an equation to be parallel or perpendicular to and our y-intercept. So from the given equation, we need to use the slope. If you need your line to be parallel, we are going to use the same slope, since parallel lines have the same slope. If our line is to be perpendicular to, we are going to use the opposite reciprocal slope. So, with that being said, in the first example, we want to write the equation of a line that is parallel to y equals negative 3x plus 7. If our line is parallel to that, what do I know the slope of our line is going to be, Drew? It is going to be the same as the slope of the line given. And then you are given what the y-intercept of your line should be. So then you're back to what we just did, plugging in the slope and the y-intercept to your slope-intercept form. Allison, what is our equation going to be then? Say that one more time. There we go. Plus 0 if you want to write it without the 0. Either way. Okay. Those are the same thing. All right, next example. This one's a little tougher. Parallel to y equals negative 1. What is the slope of this line?
0.
Good. The slope of that line is 0. So if we want our line to be parallel to that, what is the slope of our line going to be? It's going to be the same. Our slope is 0. Our y-intercept is negative 4. Again, we can substitute in to our point slope form to get the equation of our line. Noah, what is the equation of our line going to be? Y equals negative 4. If you want to say y equals 0x minus 4, that is the same thing, but I would write that without the 0x. Okay. And again, what kind of line are both of those? That have a slope of 0? Well, they're parallel, yes. Those are both horizontal lines. Okay. Can I answer a question so far? Hopefully this is feeling like review. All right, now let's jump to the second page. This is where we are going to start using our point slope form. The first example, they are giving us a point that our line passes through. This is our values of x1 and y1. And then they are also giving us our slope, which we know is m. So we can use our point slope form. You might want to rewrite this. And all we're going to do is plug in the values that we have. So we'll have y minus, my value of y1 is 5, equals m, which is 5 again, times the quantity x minus 2. My goal is to end up getting this in slope-intercept form, which means we need to get y by itself. So what can I do at this point?
You can multiply 5
Uh-huh.
into x and negative 2, that'll be 5x minus 10.
Very good. So we can distribute that 5, and then what?
1 equals 5, that's minus 5.
And then we can add that 5 to the other side. So y equals 5x minus 5. What's different about the next example compared to the one we just did? What?
It was 2 slope.
Okay, what are you not given that you were on the last one? You're not given the slope, so that's what we need to start off by doing. So y2 minus y1 over x2 minus x1 to find our slope. So 8 minus 2 over 6 minus 4, this gives me 6 over 2, which means my slope is 3. Now I have my slope. You can choose either one of the ordered pairs given to use as your x1, y1. It does not matter at all which point you use. I just usually pick the first one. So then we can plug in our slope and whichever point you are choosing into your point slope form. I can distribute the 3 and then add the 2. Can I answer any questions? Okay. I want you guys to take 3 minutes with your table to look at the next example. You are looking to be parallel to the given line through the point given. Okay? So take about 3 minutes with your table to look at this example.
So.
What?
What's the show if we can like start the conversation or something?
Oh.
Okay.
So negative y
So it's parallel to the line. So well, your slope.
Yeah.
No.
I know, I thought I was last week.
so for the review.
I'm still not paying attention, like, are you getting focused?
So you take the opposite reciprocal, which is
Okay, I keep forgetting. I mean, 10.
Is the slope just wrong?
equal if it's opposite reciprocal. Oh no, opposite.
Leslie, what did your group do for C? Listen, please.
So we put y minus 2 equals -4 and minus 1.
Okay. Hey, guys, quiet.
And then we distributed -4.
Okay, so how did you know to use -4 as the slope?
Because it's the same as 0.
Okay, good. And then you used your point. So distribute -4. That gives you y minus 2 equals what?
Wait, what? Sorry.
Y minus 2 equals what when I distribute?
Both -4x plus 2.
Okay, then what?
When you add 2 both sides, you get y equals -4x plus 6.
Okay, very good. All right, last example. Now I'm looking to write an equation perpendicular to that given line through the origin. So first of all, through the origin, what are the coordinates of the origin? Okay, so you might want to make a note that you would be using the coordinates 0, 0 from the origin. And I want my line to be perpendicular to the given one. Perpendicular lines have slopes that are opposite reciprocals. So what I need first is the slope of that given line. But what's the problem right now? Right, it's not in slope-intercept form. So I can't just look at that and identify the slope. So what we need to do is subtract that x over. So that given line is in slope-intercept form so that I can identify the slope. And what is the slope then? -1. What's the slope of my line going to be? +1. The opposite reciprocal would be +1. So we are going to use a slope of +1 through the point 0, 0. I can distribute that 1. No need to really add a 0, so I basically end up with y equals x.